Sounds good. Sounds good.
Good morning, everyone, and thanks for joining us. I'm Carly Hopper, Government Affairs Director for Indiana Builders Association. I'd like to welcome you to our third webinar in a series called Webinar Wednesdays. These provide education on industry issues like significant changes to the residential code, job site safety, as well as some other member benefits that IBA offers. Today's webinar is about the energy efficiency requirements in the state's new residential code and will be presented by Nate Kleist and Chris Schwarzkopf with Energy Diagnostics. Energy Diagnostics is an IBA member in Northwest Indiana who works with their clients from the beginning to the end of the construction process. They'll help train your staff, trade partners, and code officials to make the process run as smoothly as possible for you. Nate's the Director of Operations at EDI and an ICC residential energy inspector, as well as a ResNet certified HERS rater, and he works with energy codes and standard development. Chris is the Director of Business Development at EDI, and as well as an NGBS Master Green Verifier, ResNet certified HERS rater, and he heads up the sales and marketing team. Nate and Chris, thanks so much for putting together this presentation for us.
Yeah, thanks for having us.
Absolutely, thank you. A couple of housekeeping items before we get started. Everyone is muted. Sorry we couldn't be in person, but this is, I think, the best option 2 that we have. If you do have some questions or you have a comment that you'd like to talk on, we do have a few options for you. If you're doing this from your tablet or your laptop or your desktop computer, you can see the icons on the top. We prefer that you use the QA option. If you're doing this from your phone, you simply tap the screen, and right at the top where it has the option to leave, please don't leave. We're not done yet, we're just getting started. But right next to it, there is the Q&A button. Just go ahead and tap that button, and your questions can be answered there. If you have a long question or it's pretty detailed and you don't want to type it out, just go ahead and raise your hand and we'll unmute you and you can ask away. We are going to break this out into 3 sections. After each section, we're going to take a short break, but that break doesn't mean you can leave. We're just going to give you a little quiz with a chance to win a prize. So go ahead, sit back, grab some coffee, start your lunch, and Nate, take it away.
All right, perfect. Thanks, Chris. Okay, so here for the energy codes. Thank you for tuning into this. This is our first webinar, so hopefully everything goes smoothly. We've done a lot of in-person presentations on this, so I think we should be good to go. And like Chris said, please, by all means, any questions, bring them up during the conversation. You know, it makes for a better presentation. All right, let's get started here. All right, so what's changing in the new code, or what changed in the new code? So some of the bigger changes are the air sealing requirements, blower door requirements, duct testing, mechanical ventilation, equipment sizing, lighting requirements, and new compliance tab. So I'm going to go through all of these things in more detail in the following slides. But there were also quite a few amendments that brought the 2018 IRC down a little closer to the 2009, which you were previously on. So there are some exceptions to meeting the energy code. If you're using a very low energy use building, so that's 3.4 BTU per square foot or 1 watt per square foot, it doesn't have to meet the energy code. Now this is very rare. So even if you're heating a garage or something to that extent, you're typically over that 3.4 BTU. So essentially, if you're not heating or cooling that space, then it doesn't have to meet the energy code. Another thing that can get you out of it is a historic district. So if you're doing renovations or building in a historic area and you get permission from the municipality to skip on some of the energy code items because it could interfere with that historic designation, then that's allowed as well. Additions and alterations. We're just going to touch a little bit on this, but these do also need to meet these energy code requirements, but there are some exceptions to that. If you're doing an addition, then anything that's being touched, so anything added on, and then anything any exterior walls that you're touching that is an existing wall, those need to be brought up to energy code. If you're doing an alteration and you're touching an exterior wall, or you're opening up the attic or something like that, you don't have insulation in there, then it needs to be brought up to the new energy code. Now, if you're doing an alteration and everything is on the interior walls, the energy code doesn't apply, and it also doesn't apply to anything that's not being touched. So, so keep that in mind. And if a code official is trying to get you to bring your whole house up to energy code, give us a call, we'll help you out. All right, so there are 4 code compliance paths. One path is new to this code. It's not a path that's really usable, so I'm just going to very briefly touch on it just because you will see it in the code book if you're looking through it. But the 3 main paths, you have your standard prescriptive path, and in that path, you have the prescriptive insulation table, which we'll go over. In that table, you have to meet that, and then you have to either do your testing or meet the air sealing table. In the prescriptive path, there are two different classifications of code requirements in the energy code. You have mandatory and prescriptive items, and they're labeled as such in the code book. So with the prescriptive path, not only do you have to do the mandatory items, but you also have to hit all the prescriptive items as well. Then you have your total UA path, which is the res check approach. Most people have heard of res check. This is also a prescriptive path, but it does give you a little leniency, a little flexibility in your wall assemblies or your overall building assembly. So you can trade off U values or R values. So if you do a little more in the attic, you can do a little less in your walls, but it's strictly your building envelope. So that limits the amount of trade-off power you have. And once again, it is still a prescriptive path. So you have to do both the mandatory and prescriptive items. Then you have the performance path. This path allows for more flexibility. It takes not only into consideration the envelope R value and U values, but you also can get credit for good test results through your blower door testing and duct testing. And not only that, then you also have the prescriptive items from the code drop off. Those can all be traded off. So you do your mandatory items, and then as long as your home tests good enough and you have enough U value throughout your building envelope, then you're good to go. This simulated performance path uses a reference home that you're comparing the as-is home to. And that reference home uses the prescriptive R values and prescriptive requirements, test result requirements as a backstop. And then anything better than that gives you credit, and then anything worse than that, you have to trade off. The ERI path is very similar, except for it uses an ERI, which is an energy rating index, similar to the HERS index. And this was meant to give you more trade-off power, some more flexibility, because you can include your equipment. So high efficiency equipment can go into that. High efficiency light bulbs can help with it. But with this code, they put in a backstop of the 2009 IECC prescriptive code, which is what Indiana amended their prescriptive table back to. So essentially, you can't trade anything off with the ERI path with the amendments that Indiana had put in. So that path is really kind of obsolete for this state. So with that said, if you want to continue building with 2x4 walls and OSB, then the performance path is the path to go with. That's the one that's going to give you the most flexibility and the most trade-off power to be able to do that. Okay, so let's start with some of the prescriptive requirements of the envelope. This is the new prescriptive R value table for the 2020 Indiana Residential Code, Chapter 11. As you can see, the R values and U values were all amended back to what the 2009 IECC table were. So there's not much change there. And that also is with the performance path. These are the values that are being used for that reference home, not the 2018 IRC reference home, which was the initial code that was looked at when adopting this code. Windows. So we have some ability for trade-off prescriptively with your windows. You're allowed up to 15 square foot of glazed fenestration to not count against your U value or solar heat gain coefficient requirements. And this is so you can install a stained glass window, or if you have a window from your great-grandparents' old farmhouse that you really wanted to integrate into your house, you know, that can be done as long as it's within 15 square foot. And then same with doors, except for 24 square foot. So other than those two allowances, then the prescriptive requirement of a 0.35 U value for your windows in the house, it's an area weighted average of fenestration. So as long as all your windows average out equal that 0.35. So if you have a couple windows that are a 0.38 and then the rest of your windows are a 0.30 U value, then you should be good as long as it averages out to a 0.35. Ceiling insulation requirements. So this is a big one for confusion. A lot of municipalities try to enforce things that aren't meant to be enforced with this section. We get a lot of questions about this, about raised heel trusses. So you are not required to use a raised heel truss with this or any of the energy codes. The ICC, when they create these prescriptive requirements, they are assuming that it is a standard heel truss when they create the R values for that prescriptive requirement. Now, with that said, you can get credit for having a raised heel truss. If you use the performance path, that gives you a little more trade-off power because you do get more insulation over the top plates. And even prescriptively, if you are able to get a full R30 over your top plate, like the top diagram shows, then you can do an R30 through your whole attic prescriptively. But don't let a code official tell you that you have to do raised heel plates. Once again, if you have anybody come up and try to tell you that you have to do that, reach out to us and we can talk them through it and show them that that's not actually the case. Eave baffle requirements. This is a prescriptive requirement, but I know for us with our builders, we highly suggest you do this as a mandatory requirement if you have a blown-in insulation. If you don't have these, then you can get a lot of wind washing, and if you have soffit and eave vents, and then that can cause all sorts of issues. If you don't have any insulation above your top plates because of that, you get ghosting, you can get a lot of infiltration coming in, causing drywall issues and comfort issues. Access hatches and doors. This is also pretty much the same as the 2009 IECC, except for they added one exception. This was always an unstated exception in the 2009, but they decided that they needed to clarify that if you have a vertical door to your attic space, so similar to the door here on the left, as long as it's an insulated door, you don't have to have the insulation bat attached to it that is equivalent to the R value of your attic itself. So if you have an insulated door, you're good to go. Everything else, if your attic access hatch must have insulation prescriptively to the equivalent of what the R value is of the attic. So for Indiana, it's an R38. So you would have to have, say, an R38 bat or R38 foam board attached to that lid. And it does need to be attached because if it's not, homeowner will pop up into their attic, The bat gets stuck on the baffle, and then it just stays there. You drop the lid, you have a big gap, and it's essentially like there's no insulation. And it's the equivalent of having a window open all winter. Another couple things that are required for your attics. There must be markers installed, at least one per 300 square foot. So inspector can pop their head up there and check the depth of the insulation in the attic. And then if you do happen to have equipment installed in the attic, like a furnace or something like that, and it can't be maintained from the scuttle hole, then you have to provide a catwalk to that equipment so the person going up there does not damage the insulation. All right, above grade walls. So this is something that is very important. Insulation, if it's not installed properly, doesn't do its job. So insulation shall be installed per manufacturer spec. Manufacturer spec is typically a grade 1, grade 2 type of install. So insulation installs are graded on a 1 to 3 scale. A 3 is the worst job, and a 1 is the best job. So if you can see on the right, we've got a grade 3 insulation. That's not what we want. You don't want the insulation compressed. You don't want gaps. You want to have your outlets cut around. You want a nice level install, like on the right-hand side, grade 1. So it's nice and even, cut around all the outlets. You don't see any compressions. You don't see any gaps where there's insulation missing. That's what you're paying for, and that's what you should be getting. Frame floor requirements, this is similar. So if you're doing a standard frame floor, like a floor above a garage or a cantilever floor or something like that, when you're installing the insulation must come into contact with the subfloor. So if you can see on the left-hand side, this insulation's hanging down and there's a big gap between the subfloor and the insulation. You don't want that. That's not a good install. Air can get through there, defeats the purpose of the insulation through convective loops, and that can cause a cold floor. So like a cold bonus room, something like that. Improper install of that insulation is one of the major causes of this. And typically not the HVAC, which they're the guys who get blamed first for that cold bonus room. And then on the right-hand side, there's some metal stays that are holding up this insulation, making sure it's staying in contact with that subfloor, and that is a good install. I got a question here. What about, so here's the question, what about if the insulation is just for sound batting? Yeah, so if you have insulation in the floor between floors where it's not connected to an unconditioned space, then the insulation isn't needed, so you can put it in however you want, as long as it's doing what you want as far as the sound batting, keeping noise between floors down. That's totally fine. This is just for if it's common to, say, a garage or exterior space. Okay. All right, below grade walls. So, oh, another question. Okay, here's the other question. Does this also apply to the catwalk area above when furnace is in the attic? So,
that's a good question.
Yeah, so I'm trying to think, I'm trying to envision what you're actually talking about. So if it's above your attic insulation, then that's all that, then it's outside of the conditioned space, so you don't have to worry about that. Now, if you have a room up in the attic where your furnace is, then that's a different story. Then that floor that furnace is sitting on, that insulation should be in contact with that subfloor if it's common to that common space. So that would essentially be a conditioned floor from the bottom from the bottom of that flooring down. Now, once again, if it's completely above your attic insulation, then it's outside of that conditioned space, and then you don't have to worry about it. Okay, below grade walls. So basement walls, this is pretty standard. This is how it was in the 2009 code as well. The basement wall insulation prescriptively must be installed from the top of the wall and then down 10 feet below grade or basement floor, whichever is less. So if you have a 10-foot basement, it needs to go down 10 foot. If you have a 8-foot basement, then obviously you're not going to go lower than 8 foot. Then your crawl walls, it's the same. And then once again, prescriptively, not only do you have to go from the top and then down to the bottom of the crawl wall, but then you also have to go an additional 2 foot, either vertically or horizontally. So mind you, this is prescriptive. So these are things that get traded off through the performance path. We've never had a home in the performance path that needed that additional 2 foot for their crawl walls. When you're installing your vapor retarder in your crawl space, you want to make sure that your seams overlap 6 inches, and that you also go up at least 6 inches on the walls and on any columns in the crawl space. Okay, slab on grade insulation. So this one is a doozy. I know certain parts of the state, there was all sorts of talk and meetings and trying to figure out how to do this the proper way in the past for the 2009 code. So technically speaking, the insulation for a slab home needs to start at the top of the slab and then go down an additional 2 feet prescriptively. So down below, we have the different options of how this can be done. And now this, when you start bringing in monopore slabs, then that takes out some of these options. But what the option that we do see most often is the one over here on the very right-hand side, the bevel cut. And I know there's always a concern that bevel cut is going to make that little portion of the slab weak and it could chip away, but we haven't seen that happen even when that area is being carpeted and there's a tack strip put in there. Typically, we don't see issues there. So that is a good way of doing it if this is the style of slab you're installing. And then if it's not, then we can get creative. Also, the performance path can allow for some types of trade-offs. So that gives you a little more flexibility with the slab on grades. This also includes walkout slab. The walkout section where that portion of the slab's on grade has to be insulated as well. Okay, so this is the first portion where there's a pretty significant change with the new energy code, and it's the air leakage requirements. So the building or dwelling unit shall have an air leakage rate of 5 ACH at 50 or less. So 5 air changes at 50 pascals or less. The previous code was 7, so that's a pretty significant change there. And this 5 ACH is what the reference home uses for the performance path as well. So you would have to to get trade-off value, you would have to test at less than 5 ACH to be able to trade off and get your 2x4 walls. Now there's also another option that was amended into the Indiana Energy Code. So you can either do the blower door test or you can do the visual inspection with the table N1102.4.1.1. And that's the table in the top right corner. I know that's not really readable, but I have a bigger portion of it on a different slide. So you can do either or. Now, one thing to note is if you're doing the visual inspection, every single one of those line items must be met. And then if you're going performance path, you have to do the blower door testing because that's how you get your trade-offs and that's how you get the simulated performance. So to use that table, you would essentially be doing the prescriptive path. So to either meet that table or to get the air changes that you need, obviously you're going to need some good air sealing, a good air sealing package. So that it includes installing air barriers and then using different air sealants. So as long as it's an approved air sealant on the energy side of things, and then also you want to be mindful of the fire code as well. There are certain products that can and can't be used in certain areas due to the fire code. But you can use most anything, caulk, foam, silicone, mastic. But one thing that is not an air sealant is construction adhesive, unless it is an advanced product that does both, and it would be rated as both. But your typical construction adhesive is not an approved sealant. So when you have to air seal your bottom plates, in the past we've gotten, well, we glued the bottom plates down, so that should be good enough. But it's not, it doesn't meet the energy code requirements. And we can guarantee you that it doesn't air seal very well. So if we were to test a house like that, there would be a significant amount of air leakage coming from those bottom plates. And then air barriers, as long as it's installed properly, almost anything can be used as an air barrier. You got drywall, OSB, even cardboard, Tyvek, VisQueen, which we do not suggest using VisQueen for much other than your vapor retarder in a crawl space, because it does trap water in, and that's something that you do not want in your wall assemblies. But as long as you seal the seams and use cap nails or cap staples or tape the heads of the nails or staples, then it's an air barrier. I've got some other examples on a later slide. All right, so this is that table. So the air leakage, air barrier and insulation installation table. So once again, if you're doing the blower door test, then as long as you meet that 5 ACH, you don't have to technically meet everything on this list. But if you are not doing that and you are doing the checklist option instead, then all of these items do have to be hit. So we don't have time to go into all of these in detail, but it is in the code book. So just if that's the way you're going, make sure you're aware of all these things and that you're hitting them. Now I can say that this does not guarantee that you would be at 5 ACH or less. So we've tested homes where, you know, they were on the 2009 code and had done this for a long time, never had a test done, but decided they wanted to take advantage of the performance code. You go in and test the house and it's, you know, at set 9, 8, 7 ACH until we get in and show them, you know, there are spots that are tricky to see that should be getting hit, and it's kind of eye-opening for them. There are some things that are required though. Your new wood burning masonry fireplaces, those need to have a tight fitting flue damper or door, either or. And this is just for wood burning masonry. So if you have a kit system, you don't want to do anything that's not per manufacturer's spec with the kit. And then your can lighting must be IC rated. And that is important. They do work, but you have to make sure you install the gasket with it. If you lose the gasket, then just use some caulk and caulk the penetration. But they do work. If you're having trouble getting to the 5 ACH or less, there are definitely some good areas for you to hit. So all joint seams and penetrations, your top and bottom plates are big ones. Utility penetrations, anything that is penetrating through to the exterior space. So plumbing, HVAC, electrical, all of that should be sealed up. But then some of the other sort spaces, if you're building like a duplex or townhome, something like that, where you have a shared wall, those are a lot harder to get to the ACH requirements. And this is due to that common wall. When we're doing the testing, you're testing it as a unit. So you do get leakage from the side units as well. This picture here in the middle, that's the top plate. That's in an attic looking down, and that's actually an interior wall. If we were to turn the light off here, you'd see light through both of those seams. Those are actually a pretty significant leakage spot. That's all attic unconditioned air getting into your wall cavities. So we've found that hitting those dramatically helps that ACH, and it's something that does get missed. We got a couple of questions. Oh wait, no, these are just the same ones. Sorry. Okay, so then HVAC penetrations, these are important as well, especially the boots, because not only do they affect the blower door testing, but they also affect the duct test results. So any boots that are penetrating your envelope. So if you have duct boots in your ceiling that is connected to the attic, that must be sealed. And like I said, that will not only help your blower door results from the leakage from the attic, but your duct test results as well. All right, this is our last slide on the envelope. So your common air barriers and air sealing sections that can get missed, that need to be hit. So first off, on this top left picture, we have a bathtub on an exterior wall. And as you can see, we have the air barrier behind that wall, which is extremely important. Not only does it helps keep the insulation where it's supposed to be, but then it also helps keep air getting in behind this tub. Any air that you get in, exterior air that you're getting in behind that tub causes that real cold tub floor whenever it's cold outside. So like in an older home, I'm sure some of you have noticed that you step in the tub in the middle of wintertime and it's freezing cold. Well, that's because there's probably no air barrier and the bottom plates aren't sealed behind that. So there's just a bunch of that cold winter air getting in there, making the tub cold. So if you do this right, you shouldn't have that issue. And then on the top right corner, we have our air barrier on the attic side of this knee wall. So that's extremely important. For insulation to work, you need 6 sides of contact. So you have your drywall over here is your air barrier, then you have your wood studs, you have your bottom plate, and then you have your air barrier on the left-hand side on the attic side. And then it's also extremely important to hit that top plate on that knee wall. If you don't have that top plate, then all this unconditioned attic air gets into that wall cavity and then can cause issues, can cause an uncomfortable bonus room once again. And then if you see down in that flooring where that second arrow is pointing, that blocking is extremely important as well. If you don't have that blocking in the floor, then once again, you've got all this attic unconditioned air getting into your conditioned floor in that, say, that bonus room or room above a garage, and that's going to cause issues. So then you have the blocking in the bottom left picture. This blocking is between conditioned space and the garage. So not only is this good for energy, but it's also good for safety. You don't want the toxins from your garage or the CO from a car running warm enough in your garage or whatever getting into your house. So this blocking is important. What we find a lot is this blocking gets installed, but then the trades will come in and knock one of them out to run some plumbing or run a duct or something like that, but then it never gets replaced. So it's important to make sure that after the trades come through that blocking is still there. And then on the bottom right, this is one of my favorite pictures. This is like a perfectly installed air barrier. This is what it should look like. This is how it actually does its job. So you have your seams taped. It cut around the framing and taped instead of just draped over it. And then you have your cap nail right there being used. So this is a great example. There are times where we go into a house and there'll be a air barrier like this, but it'll just be kind of attached and then hanging over those rafters. That just allows a bunch of air to get up under the air barrier and it's not doing its job. All right, so that's it for the envelope. Do we have any questions, any additional questions? Oh, here we have a couple under chat. Sorry, I didn't see these. They weren't in the Q&A portion. Okay, so 2 questions here. What about sealing around smash plates? So,
Not quite familiar with smash plate. Can you elaborate on that a little bit? Talking about like a mud sill on the bond or the box sill?
and then while you're typing that out, Chad asked, can we get a copy of these slides? And yeah, we should be able to do that. Okay, here's another question. When it comes to sealing the register boots, is the crawl space considered a conditioned space? It depends on how you build the crawl space. So if it's an unvented, insulated, conditioned crawl space, then yes, it's considered conditioned. But if it's a vented crawl space where your insulation is in the floor instead of the walls, then no, then it would be unconditioned. So typically what we see nowadays, most crawl spaces are conditioned.
Yeah, the testing portions of that, if your crawl space access is inside the house, your energy rater is supposed to open that hatch, so it brings that space into the pressure boundary. So any leakage then is not considered leakage to outside. It gets real difficult though when the access to that is either outside or if it's in the garage, and we can't bring that crawl space into our lower door test. So it gets real tricky testing crawl space homes. Best thing to do though is to just go ahead and seal them. You'll prevent that crawl space smell from coming into the house, and it will actually help the performance of the system itself.
Yeah. Okay, smash plates are around the plumbing. So yeah, you would want to seal that if it was common to an area going to exterior space. So if it's between floors, it's not as necessary. If you're really hunting for CFMs though, or ACHs, then I would still seal that between floors because you do get some exterior air in your floor cavities. But you definitely want to seal that in, like if it's your top plate and going into an attic or going into like a framed floor where you're going into an unconditioned space.
Yeah, those smaller homes and row homes and duplex style houses, you'll be chasing CFM and trying to get to that lower air change. 5 air change, thankfully Indiana got it right and we didn't have to hit 3 air change just yet. But we know that 5 air change on a multifamily slab on grade home is pretty difficult to achieve. So if you think it's going to leak, odds are it's going to leak. You might as well have it air sealed.
Yeah. All right, good questions. Anything else before we move on to the quiz? All right. Quiz time. Chris will take this over.
I love giving stuff away for free. So to get this right, I would really encourage everyone to use the Q&A section. That's what's up on my screen right now. So if you put it in the other one and you are the first person to answer, I apologize. Please use the Q&A one. What we're going to do is we're going to ask a question, and the first person to answer or the first answer that comes through, the first correct answer that comes through Q&A, will receive it's a $10 e-gift card. All right, so answer number one, what path should I use if I am going to build with a 2x4 wall assembly and OSB sheathing? Performance. Scott Tiller, congratulations. Writing your name down.
All right, nice job, guys. He was the fastest typer.
Everyone that answered got it right too, so good job, everyone. Don't worry, there will be more questions.
All right, on to the next section. So this section has the most changes in it. We're looking at the mechanical systems and equipment. I think, yeah, the HVAC guys definitely took the biggest hit with the new code. There's some good changes in it, and then there's some things that can be difficult unless you work around it, and we have some examples of how to work around those certain situations. So in general, the mechanical system and equipment efficiency is currently set by federal law. So your equipment efficiency has nothing to do with the I-codes. Federal law mandates that. So you have, for your ACs, you have to have 13C or better. For furnaces, I think it's still at 78% or better. You know, most people are doing at least an 80%, if not a 92 or higher, 2-pipe 90. The I-codes do cover your controls, the ducts, HVAC insulation, surface water heating, mechanical ventilation, equipment sizing, your snow melt and pools. So most of these items are mandatory items, which mean they have to be done regardless of the path that you use. There are a couple exceptions to that. There are some prescriptive items that can either be dropped or traded off, but we'll go over those in a second. All right, so this is the one addition to this new code that can be troublesome. So it's the open combustion equipment room. And this one is definitely a lot easier to communicate in person with a little conversation, but we're gonna attempt it. So if your equipment room requires you to bring outside combustion air in, so combustion air either from the attic or from exterior space, due to the fact that you don't have enough volume in the house or in the space that that your water heater is installed, or if you are using an 80% furnace. So if you're having to bring in outside air for that combustion room, then that combustion room must be separated from the rest of the house. So even if that combustion closet is in the middle of your home, you would have to treat it like it's a separate space. So you'd have to insulate all 4 walls, you'd have to insulate the ceiling and the floor, and then you'd have to air seal that room and install an exterior door system, which can be a pain in the butt and added cost. So there are several ways to get around this. Obviously, the first option would be a 2-pipe 90 furnace. So your combustion air is direct combustion air. So you're getting it directly from the outside already. It's being piped out itself. And then for your water heater, either doing an electric or doing a 2-pipe gas tankless system on the right-hand side. Typically, nowadays, what we're seeing that's needing the added combustion for your combustion room would be your water heater. You know, even your power vented water heaters require combustion air, but typically it's not that much. So you can use your interior volume for that. So you can either put in a bypass from the combustion room into a bigger room, or if you're installed in a basement, something like that, there's already plenty of volume down there. So the moral of this story is just to try your best not to have to bring in exterior air to your combustion room, and then that requirement of the combustion room requirement doesn't apply then. From what we see with our builders, it's typically only in like the small duplexes or something like that where they've had to get kind of creative to get around this requirement. Okay, duct tightness testing. So this one has changed quite a lot as well. But looks like we have a question real quick. Okay, how does the new code affect appliances placed in garages? So you can still do that. You can still have them placed in garages. The biggest change, well, there really isn't anything new from the 2009 that still treats it the same. You just have to make sure that if you have ducts that are in that unconditioned space, that they are insulated, and then just that your cabinet is sealed as best as possible. So then, if let's say, for instance, you had that garage closet that you have your equipment in, if that wall between the house and that closet is insulated and air sealed, then it's already apart from the house. So you would be meeting that requirement if you're bringing in any additional combustion air, which you probably wouldn't be. So it really doesn't affect it any different than what the 2009 did. All right, good question.
That portion is tricky to get through without pointing and being live in person.
Okay, a couple more questions. So combustion air can come from the garage versus the outside, correct? I don't think so. I mean, it's not an energy code thing, but I don't think that you'd be able to bring garage just because of safety reasons. Carbon monoxide reasons, things like that, your VOCs from any chemicals that might be stored in the garage. You can bring it from the attic though. So I would say attic or exterior space.
Next question was, would the garage closet be required to meet code?
Would the garage closet be required to meet code? So as long as, well, it depends on where your air barrier is. So if the wall the back wall of that closet is common to the conditioned space in that closet, and that's insulated and air sealed, then you would be good. Now, if that was uninsulated and you brought the insulation, then you'd have to bring the insulation to that exterior wall and around the four sides.
Yeah, so it depends on the equipment as well. If your ductwork is insulated, then you don't have to bring it in there as well, too, correct? Well,
yeah, you wouldn't if you're not bringing in that combustion air. So if you're not bringing in that combustion air from outside, then yes, however you do it, it's fine. It'll meet as long as you have insulation and an air barrier at some point in that closet. But if you are bringing in that combustion air, then as long as it's separated from the house, so if you have that wall between air sealed and insulated, then it meets that requirement.
John's got another one.
Yeah, seems counterproductive to make a sealed closet and then pull unconditioned combustion air from the attic. Well, that's the whole point of them making you seal that closet, is because they don't want that unconditioned air getting into the rest of the house. Even though, you know, you're going to get some leakage from your furnace cabinet, but that's why we measure the duct leakage, why there's the duct leakage requirements. So the reasoning for that is because in the past, you would have that unsealed attic, you'd bring in that exterior air and it'd just come into your house. So that's what they were trying to prevent.
Yeah, so if you have enough combustion air inside your home, you can open up that closet to your house, but then you have to define your thermal envelope slightly differently.
Yep.
Definitely a good one, John. We've we've had that going back and forth between Nate and I ourselves. Paul's got a question.
Oh, yeah, if the unit is in the garage, yes, it can use, I'm sorry, I misunderstood you. I thought you were saying that you're bringing garage air into your house, into the conditioned space. But you're saying if your HVAC is in the garage, yes, you can use that garage volume as your combustion air. Thanks, Paul. Thanks for clearing that up. Yeah, there we go. Perfect. All right. Yeah, I knew that one was going to get some questions for sure. That's always a big topic. Oops. Okay, so duct tightness testing. This has gotten a little tougher, but the HBA, Indiana's HBA, they submitted an amendment that really helped this out a lot. It got rid of the leakage, the total leakage test, and brought in the leakage to outside test instead. We 100% agreed with this. This is the leakage that really counts as your leakage to outside. That total leakage, leakage into your house, yes, it helps with the air getting to where it needs to be, but it's not energy loss. So with the new amendment, it's mandatory that duct tightness testing is done if you have any ducts in unconditioned space. You can do either a post-construction test or a rough-in test. Now, typically we would suggest a rough-in test for your first couple duct tests for a new code, but with a rough-in test, you have to do that total leakage test. There's no way to differentiate the total leakage versus the to outside because you don't have a 100% air envelope yet. So it's a harder test. So if your air handler is installed, then the requirement is not quite as hard, and I'll go over that in the next section. So, but we are suggesting our builders just do the post-construction test because it's a much easier test. Our company as Energy Raiders, we come out and do first inspections, so we have our eyes on the ductwork prior to drywall going up anyways. And our guys are in thousands of houses a year, so they know what to look for, and they will call that out. If you don't have somebody doing that, then you might still want to do a rough-in test, at least just to get a bearing on where you're at. So yeah, so then the exception, if all of your ducts are in conditioned space, then you don't have to do this mandatory test. All right, so keep in mind, the test itself is mandatory, but then the actual leakage requirement is prescriptive, which means that it can be traded off. So these prescriptive requirements can be traded off if your blower door test is good enough or if you've done some additional installation in your home. So the post-construction test, the leakage to outside prescriptively shall be less than or equal to 4 CFM per 100 square foot. In the 2009 code, it was 8 CFM. So this cut it in half, and that's significant. Now the leakage to outside test to get to the 4 CFM definitely is not as hard as the leakage to outside or the total leakage test, which is what you would have to pass at the rough. So the total leakage 4 CFM per 100 square foot is very difficult. That's been a requirement in Illinois for probably 8 years now, and there's still guys having a hard time meeting that total requirement. Luckily, in their newest code, it went to a prescriptive as well, so they can trade it off. Got a question. All right, so question is, if the system is in conditioned space, but return air is in the unconditioned attic, would you consider the return air as inside conditioned space if it is covered with spray foam insulation? That's a good question. So as long as you have the required inches to be an air barrier. So if you're using closed cell foam, I think it's 2 inches. As long as you have 2 inches over it, then it should be considered conditioned space. If it's open cell foam, and I think that's 6 inches. So if you have 6 inches over the ducts, then you should be good. But if you don't, then it would be considered unconditioned space. Or if you just had a blown in cellulose or something like that over the top of it, that's still considered unconditioned space, unless you meet all the parameters of, there's a section in this code that goes over how to bring your duct into conditioned space in the attic. And I don't know right off the top of my head what all the parameters are, but as long as you meet that, then you could also consider it conditioned space.
Great question.
Okay. All right, so remember 4 CFM per 100 square foot prescriptively, and it can be traded off if necessary through the performance path. So what we've seen is typically what we see is you can trade off about 1 to 2 CFM per 100 square foot. So you can get up to 5, maybe 6 if you have really good blower door results. And it also depends on the size of your home. If it's a little house, it's a lot harder to trade off. All right, duct insulation and sealing. So this section does have a prescriptive and performance version as well. So insulation, all ducts outside of the building envelope. So anything in the attic space, something like that, has to be insulated to an R8 prescriptively. All other ducts except for conditioned are 6. So if it's in like a framed floor, like a floor above a garage or something like that, then that would be insulated to an R6. If you go the performance path, then all unconditioned ducts are R6 instead of doing the R8. So in the attic, you can do an R6, and in that framed floor, you can do an R6. Duct sealing, this is mandatory. And this is mandatory regardless of whether you have to do the testing or not. If you have all ducts in conditioned space, you still have to meet the duct sealing requirements. So your duct air handlers, filter box shall be sealed. The filter box is something that gets missed a lot, and it actually causes a lot of leakage in your ducts, especially if you're in the garage. Joints and seams shall comply with section 1601.4.1 as applicable. So that section is in the 2020 Indiana residential code. So it's chapter 16. And then building cavities, this was amended slightly, but it makes quite a big difference by Indiana. So in the original code, it just said building framing cavities shall not be used as ducts or plenums. But Indiana added in the word supply. So building framing cavities shall not be used as supply ducts or plenums. So you can still use these cavities for your return systems. You just have to make sure they're sealed very well, because if they're not, and you have to do the testing, those are going to cause issues. You'll have a hard time meeting that 4 CFM per 100 square foot, even if it is the 2 outside leakage, because all of your framing cavities, your floor cavities, those do get exterior air in them. That's just the nature of the beast. So what I'm assuming, or what I'm predicting that we're going to start seeing is still using those framing cavities, but HVAC guys getting a little creative with panning in areas where it's harder to seal that cavity. All right, so here are some examples of the areas that need to get hit with ducts. As you can see on the right-hand side, this is the filter box. So they've taped all the corners, all the seams, and then have the cover. This is one of those magnetic covers. And then on the bottom right, the boots, it's real important to get those boots sealed up, because those can allow a lot of air to get into your duct system, your boots, your elbows, all of that. It's mandatory that those are sealed, and then to get your test results, you definitely need those sealed. All right. All right, question. When a duct requirement is R8 performance and is placed in an attic with blown-in insulation encapsulated around it, is there a trade-off in any way? So the requirement, if you were going performance, would be an R6. And yes, if you would still need to insulate the duct itself to the R6 because it has to be independent of any other insulation. It needs to be meant for that duct. But with that said, if you're going performance, then you do get credit in the software if you have additional insulation blown over the top. Now, if you're doing an R8 prescriptive, then it has to be an R8 duct insulation. I saw Carly raise her hand. Let's see here. Oh, she's off. She got kicked off the panelist. Maybe she did that. All right, Carly, are you unmuted? She is. All right, maybe she didn't mean to raise her hand. Oh, holy cow. Okay. All right, so it looks like we're getting really close to that hour. So we had definitely a lot of good questions. Let me scream through this last mechanical portion. So if you're doing prescriptive, your hot water pipes need to be insulated to an R3 if they meet any one of these 7 requirements. These are in the code book. So go ahead and take a look. And then if you are doing a boiler system to heat your home, then any of the piping that needs to carry fluids above 105 degrees or below 55 degrees need to be insulated to an R3 mandatory. And then it's mandatory to protect any piping insulation that is exposed to weather. All right, I'm going to kind of skip over this. If you're doing a recirc system for your hot water heating, then essentially your controls have to be automated. Let's see, I've got a chat coming up. The boots coming through subfloor. What is the best way to flash and seal those to the subfloor?
We've seen a lot of products used. The best one that we've seen is like a mastic material, a paintable mastic material, where they go into the boot itself, hit the corners, hit the seams, and then pull it up over the subfloor. We've seen builders try to do like a foam on the back side of it. That doesn't always work. We've tried to foam it ourselves. That doesn't work real well. Caulk does well. There's some tapes out there that might work, but the bigger material kind of doesn't give you much room to work with when you put your diffuser in there. So the best case, or the best performing product we've seen is like a mastic, like a paintable sealant material.
Okay, so we're just for the sake of time, Chris and I will stick around for additional questions and stuff at the end. So let me get through these last couple slides, and then we'll do the questions afterwards. All right. So
and the quizzes.
Yeah, and the quizzes.
Free stuff to give away.
Yeah. All right. Equipment sizing. So this is new to this code. This is mandatory. Your HVAC equipment needs to be sized according to an ACA approved Manual J and Manual S. This should be required for permitting at the permitting stage. So when you're submitting your energy code docs, your plans, all of that to get your initial permits, you should have a Manual J as well. The heating equipment can be installed up to 140% of the sizing calculation, and the cooling can be installed up to 115%. This is for all paths. So this is something that your HVAC company can do. This is something that we as a company do as well. I'm sure some other energy raters do them as well, but this is something that it's important that they match the plans and that your energy code documents. So So we've worked with builders doing them for the builders. We've also worked with the HVAC guy doing them for the HVAC guy for the sake of making everything match up. Mechanical ventilation. So whole house mechanical ventilation, this is new as well. So we don't want to have that sick house syndrome. We want fresh air that we control coming into the house. So this is a mandatory requirement, and this is mandatory, especially if you're doing the blower door test, you're testing at 5 ACH or less, then you have to do this. Let's see here, another chat question. Okay, well, we'll come back to it. Oh, okay. Carly just said to take as long as we need, and if people need to leave, they need to leave. All right, good, because I didn't really want to rush through this one. This is pretty important. So, whole house mechanical ventilation. It is mandatory. So there are multiple ways to achieve this, which we'll go over in the next couple slides. But the building shall be provided with this ventilation. It meets requirements of M1505. That's what the section in the energy portion, Chapter 11, calls out. So you can either use this table or the equation in the top left to figure out how much ventilation your house needs 24 hours a day. Then there is an intermittent whole house mechanical ventilation table that shows you if you have if you want to do it intermittently, then what the CFM requirement would be for that. So for an example, let's say you have a 3,000 square foot home on a 3,000 square foot home on a 1,200 square foot base with 4 bedrooms. So when you're doing this calculation, you have to include your basement square footage as well. So we add those two up, it's 4,200 square foot. So if you can see on the left hand of that table, it has the square footage. So we're at 4,200, so we're between 3,000 and 4,500. And then at the top of the table, it has the number of bedrooms. So we're at 4 bedrooms. So that means that you are required to have 90 CFM of continuous ventilation for that house. All of your intakes and exhaust system outtakes, you have to have a gravity damper installed at the least, mechanical gravity damper. So if the system isn't running, it doesn't just have a bunch of air coming in that's not needed. Let's see. All right, well, I guess I'm getting a lot of questions coming through. Okay, John said he has 2 questions, but I can wait till later to answer. All right, thanks, John. Okay, so the 3 main options for whole house mechanical ventilation are exhaust only, supply only, and balanced. So your exhaust only, for example, is a continuous run exhaust fan. And how that works is the fan exhausts a certain amount of CFM. And when you're exhausting CFM out equals CFM in. So if you're exhausting 80 CFM, that puts a slight negative pressure on your house, and then your house naturally wants to balance out. So it'll bring in that 80 CFM through the path of least resistance, so natural leak points. If you do install a bypass or something like that, then that will typically be your path of least resistance, and that's where the air will come in from if you want to control a little more where that air is coming from. This is definitely the most cost-effective way to do this, not only for the builder, but also for the homeowner. Most of these fans are running at really low watts. So like the Broan ZB80, for example, that's the one that has the lowest wattage. That runs continuously at 5.8 watts. So that's less than a single LED light bulb. Panasonic, they have the Whisper Green that runs at like 11 watts. Once again, really low wattage. So then, and this can be, and that exhaust fan can be installed anywhere. It can be you can replace one of your bathroom fans, or it can be installed in a basement if you're concerned about noise. It can be installed anywhere. And if you need two of them, you can have both of them on the second floor. There's no requirements there. It's not like you have to have one on the first floor, one on the second floor, anywhere you want to put it. What we typically suggest is like a powder room or something that's not attached to the master bedroom. If these fans are installed properly, they are quiet. But if you have somebody who's a really light sleeper, and it's in their room essentially, you know, maybe they'll hear it kind of like the fridge running, and it could bother them. So even though it is the nicer fan, we still suggest putting it in a like a hallway bathroom. Then there's the supply only. The most popular way of doing this is an air cycler system where you have a fresh air line going from outside into your return system. And then you have a controller that runs a mechanical damper. So that controller gets programmed to the energy code, and then based off of the CFM that the furnace fan is pulling in when it's running, it calculates how often that damper needs to be open. And I can tell you on most homes for this system, you're going to be running that furnace 24/7 or close to it to meet the CFM requirements. To do the air cycler system, you have to have an ECM motor as part of the efficacy requirements. That's really not a big deal anymore. As of last year, I believe July of last year, all new furnaces being built and sold have ECM motors, even the 80%. But there are still going to be some of the old furnaces in the warehouses and stuff like that that you'll still see. So if you're doing the system, just make sure you have an ECM motor. And the way that works is just the opposite of the exhaust. It's pulling in fresh air, so you're supplying the fresh air in, which puts a slight positive pressure on the house, and then it pushes out the stale air out through the natural leak points. And then you have your bathroom, which the most popular is ERV or ERV. So yes, this is the best system. It is also the most expensive by quite a lot. They're coming down a little bit, but it's a balance. What it's pulling in, it's also pushing out mechanically. It's not putting any positive or negative pressure on the house. And it also helps condition or temper the air coming in with the old stale air going out. Okay, this is the efficacy table that I was talking about. Installing something for your whole house mechanical ventilation, you just want to make sure that it meets this efficacy table. We have had some code officials thinking that any exhaust fan installed has to meet this table, which is not the case. This is just if it's being used for your whole house mechanical ventilation. So if your range hood is just your range hood and it's not being used as part of that whole house mechanical ventilation, it doesn't have to meet this 2.8 CFM per watt. Okay. And let's see here. And then this is where that exception is that calls out the ECM motor for the furnace fan. If you're using your furnace fan versus one of the fans in the table, then you just have to have the ECM motor. All right, and then last for mechanical is the lighting equipment. Pretty standard. You just need to have 90% of your permanently installed lighting fixtures to be high efficacy lamps. So LEDs, CFLs. This isn't as big of a deal as when it initially came into play in 2009. We needed 50% of them, and it was, you know, the only options were these crappy CFLs that took forever to start up, had terrible light, and were expensive. So nowadays LEDs are very reasonable. It's good light. And it just makes sense. So, all right. So Chris has another quiz. Oh, well, yeah. Let's hit the questions at the end, just for the sake of time. So Chris has a quiz question.
Sure. Yeah, I've answered a few of the questions that have come through. We'll do our best to get the rest of it.
Perfect. Thanks, Chris.
But remember, Q&A answers, send them over. Question number 2. If I have a 3-bedroom, 2,500 square foot home on a 1,000 square foot basement, what is my continuous CFM requirement per the table on the slide? First question, Regina, 75. We have a 4 or 5 bedroom house. Yes, you are correct. Congratulations. Answer number 2. And your prize is another $10 gift card, e-gift card.
Okay, perfect. Nice job. All right, so this last portion is just what is required for permitting. So this should be pretty quick. So if you're doing the straight prescriptive, you just have to have on your plans showing that you're going the prescriptive path, and then showing that you're using the R values that are on this R value table, R and U values. So you submit that, and then you submit your manual J and S, and then you should be able to pull your initial permit. Then for your C of O, what you're going to need is you're going to need to install a electrical panel sticker that has this information on it. So it's just confirming the R values, your U values, the mechanical equipment type, and if you're doing the blower door results and duct testing, if it's required. If you're doing the checklist table, then you just put NA there, and if your ducts are in conditioned space, you would just put NA there, and you sign off on this. Now, then you would need your testing result papers. Submit that. If you're doing the checklist, then you would be the one installing this certificate. If you have somebody like us coming out and doing the blower door testing and duct testing, we would provide the report on the right, and we would provide the sticker. For the total UA path, it's very similar, except for permitting, you're going to submit the compliant or the res check report. It'll show hopefully a green bar up top instead of a red. If it's red, it means it doesn't comply. So you submit that up front, and then you would also submit your plans and your manual J&S. And then for your C of O, once again, you would do the sticker and then your testing reports. And then the performance path. So the performance path, you work with your energy rater during the design stage. So you would send your rater your plans and your hopes and dreams of what installation levels, what trade-offs you're wanting. They'll plug that into the software, make sure it works. If it doesn't work, we always like to, we'll do a value engineering and tweak it to where you're spending the least amount as possible, or whatever you want to do to get to where you want to get. So then you get that report, you get the manual J and S. If you choose to use the rater, if not, you get it from the HVAC guy. You submit that with your plans. Make sure on your plans that you note that you're using the performance path. So you submit that up front. And then for your permitting, so that's the report. And then for your final, for your C of O, the rater will go out on site. They'll do the testing. They'll plug in the as-is information into the software. You'll get your final report. You'll get a sticker put onto into your electrical panel, and you will get your test results. You submit that, and you'll get your C of O as long as everything passes. Then there's the ERI path, which I said you're not really going to go see. You're not going to see. But it's essentially the same as the performance path, same process. If you're doing the performance path, it makes it a lot easier to get your rebates. The performance path, there's just like a couple little added steps to get a HERS index, which all of the local rebate programs are based off of. So if you get a certain HERS score, then you're building in a NIPSCO area, I&M, Vectren, they have these rebates that are available to you. So you work with your rater, you get your reports, get the HERS report, either you submit or the rater submits to the utilities, and then you get free money. So you can never go wrong with those rebate programs if they're available. All right, so that's that. Type up your questions if you have it, and then I'm going to have Chris do this last quiz, and then we will start answering some of the questions that we didn't get through.
We did miss one quiz. So we only went 2, we have 5.
No, this will be, we got it.
Oh, you got it, okay. Do you want to answer this code, or this question real quick? What code is supposed to be used for ResCheck, as the current ResCheck still lists Indiana code as the 09?
So that's a great question. Yeah, so the DOE is not creating state-specific reports anymore. They stopped doing that a few years ago. So to me, I think I could easily explain this to a code official if we were to do it, if we were to do this. I would continue using the 2009 for the ResCheck report, because the ResCheck is just based off of the insulation table, insulation and U-value table. And Indiana amended that all back to exactly the same as the 2009. So maybe do the 2009 for your report, but then when you print the checklist that the inspector takes out into the field, go click on to the 2018 code, because that's what this is all based off of, and then print the checklist itself, because that does have like mandatory items that are part of the Indiana code. So I think that a code official would be fine with something like that, like kind of a hybrid system. I mean, if not, like I said, we'll talk to them and try to explain why it's exactly the same thing. So that's what we've been suggesting to people, and that's what we've been doing for our clients.
Okay, jumping on the question here. Question number 3: which compliance path or paths are the manual J reports required for permitting? Ooh, I think we might have stumped them.
Paul got it. All of them. That's right. So manual J's, they're required for all paths. Good job, Paul. All right, and then a bonus question.
This is my favorite question. What is the name of the company ready to provide you with all of your energy efficiency needs, certified as best place to work in 2019, and has certified over 50,000 residential units since 1992? Shameless plug. Paul, again, with the ADI. Good job, Paul. Awesome. Good work, guys.
All right.
You guys are shameless.
Yeah.
Just me.
He is head of the sales and marketing team. All right, so let's go through some of these questions that we missed.
There's a great question that I answered. I'll come back to that one. But John had a question about, you mentioned gravity damper when talking about mechanical ventilation.
Just so you know, that was a different Paul Schwimmer, I think.
Yeah, 2 different Pauls.
Yeah.
I'm assuming that doesn't apply to the intake air from the attic for mechanical equipment. So I'm assuming he's talking about the difference between combustion air and then your fresh air requirement.
Okay, so which one was that again? I'm sorry.
I don't have the right before.
Oh, here we go. Okay, so can continuously running fan, you mentioned gravity damper on intake. Is that what the one you're talking about? I'm assuming that it doesn't apply to the intake air from the attic or mechanical equipment. Yeah, if it's mechanical ventilation, so not if it's something for like combustion or something like that.
Yeah, so there's a difference between combustion air and your makeup air requirement. Combustion air needs to come it can come from anywhere, but makeup air for your fresh air requirement has to come from the outside. It can't come from your attic.
Well, combustion can, and
Makeup air, or your.
both of them can come from the attic. So I think he's asking about the gravity damper itself. So,
He's saying combustion air.
oh, did he correct combustion air intake?
So the one that comes through for your makeup air or for your combustion air.
Right, yeah, that does not need a gravity damper. Because that's direct combustion. But anything outside of that.
Okay, I did answer a couple questions, but I just want to make sure that I am on the right path. When you have a rater come to do a final blower door test, it doesn't need to be a 2009 IRC, or can it still say 2009 IECC? I have a municipality refusing to accept our testing strictly due to it saying 2009 IECC.
This is for the sticker.
My answer was the sticker and supporting documents should state the applicable code.
Yeah. So the applicable code now, if it was permitted December 26th or later, it would be the 2020 Indiana Residential Code is what the official name of it is. If it was permitted prior to that, when you were still on the 2009, then it would be 2009 IECC. But currently, Indiana does not have an IECC code technically. They're using the IRC Chapter 11, which is the same thing. It's just not in a separate book. I know it's a little confusing.
Yeah, the big thing is if you're using a performance software and it states 09, the performance software is comparing it to the wrong reference house.
Yes. Okay, so I just saw one here, Rob Fisher. He said the web application of ResCheck has the new code 2018. That's true. It does have the new 2018 code, but that is not what the 2020 Indiana residential code is. So if you're using that for your compliance, you're overbuilding, because that actually uses the 2018 IRC's actual insulation table, prescriptive insulation table, which was heavily amended by Indiana. So that's why we're still suggesting people use the 2009 report. Okay, Paul put word of caution on conditioned crawl spaces. If you insulate the box sills, do not use bad insulation, as condensation and mold behind it will eventually form. Spray foam is the only answer if you insulate box sills on a crawl. We insulated with rigid foam from the outside. Yeah, I mean, that's definitely best practice.
Crawl spaces are tricky. Paul and I have spent a lot of time in some crawl spaces together, so we know. But yes, there's always that fear of moisture in your crawl space, and a lot of times there's an underlying issue causing it. But you got to get every step right, and Paul's definitely doing a great job on his crawl spaces.
Okay, were there any in the chats that we missed? Here we go. So Pat asked, do your current clients get a $10 gift card just for being your best customer?
Absolutely.
That was his best customer plug. All right, Lynn, can we get a copy of the mandatory items for each path? I know the list is the same for each path with regards to mandatory items, but it would be nice to have it clarified in a table, prescriptive. Yeah, we could probably work on something like that points them out more. Lynn, it's funny you brought that up because it can be confusing. That's something that they're working on the 2021 code. They introduced a mandatory table essentially where they put all of the mandatory items, making it a lot easier to see. A couple request email slides. So yeah, if you want us to email you the slides, just send us an email, a reminder email to either myself or Chris. Use the email addresses that are on this page or on this slide, and we will get them sent over.
One thing, I guess I'll reach out to Paul. I've got Paul Schwinghammer and Paul that answered question number 3 and 4 correctly. I don't know if I have your last name. Will it be on the attendee list that way?
Oh, that's a good thing. Yeah. So anybody who won the prizes, please just also email us so we get the right person.
We've got Scott Tiller, Regina, Paul, and Paul.
So this question that Chris you had answered, on a 2-stage heat pump where the unit will run on low stage and cooling, can the system be oversized more than 115%? So with the two-stage systems, depending on your municipality, there are municipalities that are allowing you to use that first stage for your sizing. So yeah, if it's calling for like I don't know, I'm just going to throw out numbers. If you're calling for a 60K and your low stage is a 60K, but it's saying it's, I'm sorry, you're doing heat pumps, but let's just, so if it's saying 2.5 ton is your low stage, and that's that 115%, but your high stage is at 3 ton, which is over the 115%, a lot of municipalities are allowing that. So that is a interpretation thing there.
Usually I'm the guy with the gray area.
All right, I feel like we got most of these other questions. If you do have any other questions, pop them in now. And we'll get to them if we missed a question that you really want answered. And if not, I think we are done. Thank you for hanging in there and listening to the super exciting energy code. If you have any additional questions, feel free to reach out to us. We're always happy to help out. And Carly, do you have anything to say? I think I've got you unmuted.
Just wanted to thank you again for your presentation. It was super informative. Thanks to all of you for participating in the webinar today. We are planning a couple of additional webinars in June, so look for details on those in the coming weeks. Everyone stay safe and enjoy your day.
Awesome, thank you.
Thanks, Carly. Thanks, everyone. I'll just unmute everybody, see who's left.